Hello, today we are going to learn about average atomic mass. We're already in week 15 of NTI, and we're going back and looking at the periodic table and talking about the one number that I said ignore for a while. That's right, this number right here at the bottom of the periodic table square for each element, that is the average atomic mass. And we're going to do a little bit more than just talk about it. You're going to learn how to calculate this number. And before you freak out thinking, oh no, big long math problem, it's really not that bad. As long as you follow the structure that I'm going to show you in this video, you'll do just fine. So what is the average atomic mass? It is the average mass of all the isotopes known for that element. All right, so let's talk about oxygen. All right, if you look at oxygen on the periodic table, all right, O, you'll see at the bottom it says 16.00 on most periodic tables. Okay, this is the average atomic mass right there. All right, well, oxygen has 3 known isotopes. It has oxygen 16, oxygen 17, and oxygen 18. This is the true mass, but we just go ahead and round it to 16, 17, and 18. Now, what I want you to look at is what I'm underlining right now. Percents. What is this percent? That is the percent abundance. All right? It is the amount that isotope happens in percent. So if you look at it, oxygen 16 happens 99.76% of the time. So that means of all the oxygens in the universe, all right, 99.76% of them are oxygen 16. The other 2 isotopes of oxygen happen far, far less. I mean, 0.04%, that's almost too small to even count, right? Well, scientists have gone ahead and they've discovered and they have calculated and they have looked for almost all the isotopes for all the elements on the periodic table. All right? And they have calculated the average atomic mass for you. All right, so why in the world are we going to go ahead and learn the calculation? Because it helps us understand a little bit more about isotopes. It helps us understand where we're going next with when we go over ions and stuff. All right, and it's just a good thing for you to know how to do. It's one of our standards. All right, so we're going to look at this average atomic mass calculation. What I'm going to do is I'm going to give you certain amount of isotopes for an element. So like oxygen, there are 3. I'm going to give you their masses and how often they happen, their percent abundance, and you have to calculate the average atomic mass. Okay? Well, how are you going to look over here? I didn't give you the abundance. I gave you the percent abundance. Oxygen 16, it was 99.0. Well, here's how we do it. Here's the basic calculation. All right? First, you list the 2 isotopes. So for, like, say, for oxygen, I had oxygen 16. And we'll say oxygen 17. We'll forget about the 18 right now. We're just using this example. All right. I list their mass. Okay, this one has a mass of 16. This one has a mass of 17. Then you multiply it by the abundance. Now, what is the abundance? It's the decimal. All right, well, so what do? This right here. You just take that divided by 100. So 6. And then I'm going to divide it by 100 so I could get a percent. But, if you type this all out, it calculates it for you. All right, 17 percent. We divide that by 100 to get it out of the percent, and we just calculate it. And if you look at it, once you calculate it, you got 2 answers. You got answer 1, and you got answer 2. All you got to do is add those up, and you get the average right here. So we're going to work at on practicing this, and I'm going to erase this so it's a little bit more clearer to see. All right, if you were to screenshot anything for your notes, all right, this would be the slide, and once I clean it off, then you should probably screenshot this, take a picture of it. All right, use this for your notes. Okay. Now, I'm going to practice through 3 examples. Okay. Your homework is going to be 5 questions about this. All right. I would calculate the whole answer for, like, say, isotope A, then calculate the whole answer for isotope B, and then add up the 2 answers, and that would be your average atomic mass. So let's go ahead and work through the first example. So you could see the abundance as a decimal, or you could take just simply the percent divided by that. We times it by the abundance as a decimal, so times the talking about. It's a lot easier to see what I'm talking about by working out problems. All right, so the first part is we list the 2 isotopes. If you look at it, it says calculate the relative atomic mass of bromine. The 2, I'm looking for 2 isotopes that I'm going to calculate. Okay, isotope, we'll just say isotope A has a mass of this, 78.92 AMU. All right. Isotope B is 80.92 AMUs. Okay. Okay, well, I'm going to multiply the first one by 100. Well, look, there's the percent. So 50.969. And we want this as a percent, so I'm just going to divide that by 100. Okay, I'm going to put an equal sign there. Okay, I'm going to multiply the mass times the percent of the second one. 49.31 divided by 100. Pretty much everything I give you is going to be in percent. So as long as you remember to put the divided by 100, then you will get it in the decimal form. Okay, well, if I went ahead and calculated this. So the answer for the top one comes out to be 40.00. The answer for the bottom one comes out to be 39.90. You add these together, you get 79.90. And this is in AMUs, all right, because it's a mass. And this is the average atomic mass for bromine. So you calculated it. If you followed along with me, you calculated the average atomic mass for bromine. You simply take the mass times the percent, divide by 100 for each isotope. All right, well, this only had 2 isotopes, so that's not that bad. Percent divided by 100. Let's go on to one that has 4 isotopes. It's the same thing. All right, it's the same thing. I could say, okay, I have isotope A, B, C, and D. Okay, it doesn't matter what you name them. Okay, so let's look at the first one. Here's A. P-10. We know from our way of writing it that we write out the name followed by the mass number. All right, so 10 is the mass. So I write 10 there. All right, well, what about the next one? Okay, this would be P12. So 12 is the mass. All right. I got C, which is 13, and D, which is 15, as the mass. All right, because we're following along with this right here. It's the name followed by a dash and then the mass number. Okay. Well, what's the next step? Okay, so for P10, it's 31. So times 31 divided by 100, because we have to get rid of the percent and put it in a decimal. All right, for B, it's 5%, so times 5 divided by 100. Okay, for C, it's 5% again. Okay, and then for D, it was 60%. So that one happens the most. All right, well, I'll calculate these out. I get 4 answers, which I then add up for my average. Okay, the average for A, the answer for A is 3.1. The answer for B is 0.6. The answer for C is 0.65. The answer for D is 9.0. Add them all up, and you know what I get? 13.25 AMUs. Okay, so as you're doing this homework, or as you're doing problems like this, there is one way you could check to see if your answer is relatively right. So, if you don't want to do like all the math over again, how could you tell if it's right? Well, I know that the lowest mass was 10, and then the highest mass was 15, right? My average atomic mass has to be in between these two. That's the way averages are, right? The average could only be in between the lowest and the highest of any kind of average. And last time I checked, 13.25 is in between the 10 and the 15. All right, so say I got like 22 as my answer. Well, that's not in between 10 to 15. So that means I did the math wrong. All right, that's just a quick way to check your answer. But it's still following the same process. I list the isotope, the mass, I times it by the percent, divided by 100, and got an answer. I did it for all of them, added up the answers, and I've got my average atomic mass. All right, well, what about one with maybe a little bit more difficult numbers? This one was pretty little numbers. 31, 5, 5, 60. It made nice, clean numbers to look at. What one that looks a little bit more difficult? All right, so here we go. This one is written as difficult as I could write them out. And you're going to see that it's still the same process, all right? Okay, and we're going to read through it together. Okay, it says element X has 3 isotopes. Okay, the first one, X40, happens 30% of the time and actually weighs 39.67. Oh, so we're getting like really exact weights. We got X45, happens 10% of the time and weighs 45.0001. And then we got X35, which happens 60% of the time and weighs 34.989. Okay, so we're going to figure out its average atomic mass from this information. Okay, so let's start off. We're going to list our first isotope, X40. And what did it say was its actual mass? It said its actual mass was 39.67. So we're being super exact. We're not using 40 as their mass. We're using what it was before we rounded off, 39.67. And yes, I'm aware that rounds off to 40. Okay, then we have X45, which has a mass of 45.001. And then we have the third one, which is X35. And as you see, this is a made-up element because we could do this for any element. I could give you the element, R in, and we could find out what it is. It's like a mystery element. The mass for 35 was 34.989. Okay? Well, now we times it by the percent, divided by 100. So times by the percent, it's 30 divided by 100. Okay. The second isotope happens 10% of the time, so times 10 divided by 100. And then the third one happens 60% of the time, so times 60 divided by 100 equals. All right, and we get answers for these. Answer for the top one is 11.901. Answer for the middle one, 4.500. And you're probably asking yourself, well, how many places after the decimal do I need to put if I get answers like this? I don't know, 2 after the decimal is good enough for me. All right, add these up. You know what I get? I get 37.39 AMUs. This is my average atomic mass. And if you look, it is in between the lowest and the highest. So I had a range from 35 through 45, and yep, that is in between them. And if you look at it, the answer was 37.39 AMUs. The average was closest to the one that happened the most. That happened 60% of the time, right? So the average was closer to that. I mean, come on, think about it. If you had 5 A's and 1 F, your overall grade is going to be closer to the A's, right? Because that's the one that happens the most. That's how averages work. All right, so if you have any more questions, text me or your teacher, and start practicing on the work. Goodbye.